Hello, dear authors and invited guests. Welcome to technical session 6A. Good morning, good afternoon, and good evening, wherever you are. It is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time, and we will together pass this soon. We hope you will enjoy 2 days of knowledgeable and interactive sessions. Just before we get started, I would like to introduce you to the chair for this session. So the chair is Dr. Gul Erkal Bayram. Hopefully I said that properly. And just to give you introduction to her. So she's an associate professor in the School of Tourism and Hotel Management and Department of Tour Guiding at the University of Sinop, where she has been a faculty member since 2016. She's also head of Tour Guiding Department. Erkal Bayram completed her PhD at Sakarya University and their undergraduate studies at Baliski University. She has also been a professional tour guide for 10 years. Her research and interests lie in the area of tourism management, policy and planning, organizational behavior, tour guiding. So just going to move on to our first presenter. Also, with the papers, there's a special note for the presenters. You'll be given 12 minutes for the presentations. On 10 minutes, I'll raise a gentle reminder, and I request while the presentation is going on, other participants be kindly muted. So the first presenter is Norman Grudsis from University of Latvia in Latvia, and their paper title is Adapting Automatic Speech Recognition to the Radiology Domain for Less Resourced Language, the Case of Latvian. So whenever you're ready, Norman.
Yes, I'm ready. I will share my screen. Well, it seems that I have to relaunch my Zoom to allow screen sharing. Can you wait for me for a few seconds? I'll quit and rejoin. Sorry for this. All right. So hopefully you can now see my screen, right?
Yes, right.
Thank you. So good afternoon. My name is Normons Grūzītis. I'm from University of Latvia, and I will present you a joint research and innovation project that we are implementing together with one of the largest hospitals in Latvia. And the topic is about speech recognition, specifically for radiology. But before I start with the technical details, so first of all, about the issue that we are trying to solve. And so the current situation in Latvia, and also, as I know, in other countries, well, in many countries, of course, there are already speech recognition applied to this domain, but still in some countries, it's still not the case. And the current situation, at least in Latvia, is that, in all the largest hospitals and private clinics, the case is that well, a radiologist in this case takes an image, whether an X-ray or ultrasonography or magnetic resonance, and etc. And then he or she looks at the screen, and it's not possible to turn the head or write something down. So the doctor has to focus on the screen, and he or she dictates it, well, either in a device and then sends a file to a transcriptionist center, or sometimes directly picks up a phone and calls in to the transcription center and dictates what he or she sees on the screen. And then this file is dispatched further to the one or the other operators at the hospital, and the operator listens to the transcription and completely manually, from scratch, writes down the final description of this examination, then sends it back to the radiologist. The radiologist has to check that everything is correctly transcribed, and then clinician and patient can receive this report. But well, in case of a large hospital, so in case of our partner, so only radiologists are producing daily more than 100 dictations, and during a month, it's nearly 200 hours of dictations that have to be transcribed. And they are employed for this particular hospital. There are employed more than 30 transcriptionists in this at this center. But still, it requires a lot of time to transcribe each examination, and therefore every operator can transcribe monthly only about 5 or 6 hours. So it takes a while. And but the biggest problem is that patients and clinicians have to wait even for a day or two for this report. So this is the principal issue here. And of course, patients and clinicians would like to receive those reports as soon as possible. And from the radiologist's point of view and transcriptionist's point of view, of course, there is a need to minimize this time and effort. And it's important also this effort that has to be put into this work of transcription, producing transcriptions. So from this project perspective, however, the aim or technical aim is, well, first of all, to develop, or more precisely, to adapt a Latvian speech recognition system specifically for the radiology domain. And for Latvian, there are already available general purpose speech recognition systems for general domain, like news, etc. But we need to adapt this technology for the very specific language of medicine and radiology in particular. And this also involves creating required language resources so that we can train and adapt this system. And the other part of this project is related to developing a platform for convenient, well, first for processing, submitting all those dictations for transcription, but most importantly for convenient post-editing. And so since the beginning, we assume and we accept that, of course, there will be errors in these automatic transcriptions, but then our task and mission is to provide a convenient environment so that it takes as little effort as possible to post-edit the automatic transcriptions to make the final report. And so here are 2 slides that just visually show what we have built so far, and this is an intermediate version of this speech recognition system for radiology. And so this is this post-editing interface, which well, either an operator at the transcriptionist center or the doctor himself or herself can use. And what this environment primarily supports is alignment between text, the automatically transcribed text, and the audio. So the transcriptionist or doctor can move and navigate through this text, and always the audio is synchronized with the position in the text. And also there is the current word that is being pronounced or played is always highlighted. So it's always the possibility to just stop the recording, to edit this specific word form or phrase and move on. But then, of course, I'm sure that you cannot grasp the content of this screenshot, but at least the functionality of the interface, hopefully. But of course, well, then what the automatic system does, it transcribes the dictation as is, and all the numbers are transcribed in full words, etc. And of course, this is not the desired result, and therefore we also need some post-processing, automatic post-processing, so that numbers are actually collapsed and rewritten as numbers, and the different symbols are written as either as acronyms or abbreviations, etc. So and about the so as I mentioned, to build such a system and everything behind the scenes, so this speech recognition support in particular, we need language resources. And so Latvian language is it's a rather small language, only about 2 million speakers, but it's very inflected language, so many word forms, many inflections. But it's also, despite being a small language, it's not less resource. Well, it's not low resource, but it's also, of course, less resource than other bigger languages. But still, we at least have many language resources we had already before this project. And what we had to create were 3 specific resources to adapt a general domain speech recognition system to this particular radiology domain. And number 1, we had to create a large text corpus to train and adapt the language model that will predict and select the most probable words in the text. And for this purpose, we used the archive of this hospital, which contains reports from the previous 10 years, more than 100,000 reports. And from this, we trained the language model. And then we also used some recordings from the previous year to create a speech corpus, and the speech corpus was used to adapt the acoustic models and to evaluate the performance of our system, and also pronunciation lexicon, which is required, which well, specifies which are the actual words that can be recognized and what is their correct pronunciation and orthographical form. And I will skip some slides since time is up.
Sorry, Mr. Nordmunds. You have 1 minute. If you more quickly answer, please.
Thank you. I will then skip those details about each of those resources. You can find them in the paper. But then in the result, what we have currently achieved is a system whose accuracy in terms of word error rate is somewhere between 20 and 60%, depending on the specifics of the reports. But well, this is just an indicative result, since the test data set is not very consistent and clear. But nevertheless, so of course, for academic purposes, we allow all those tables with persons. But the actual key performance indicators that we are interested in is to reduce the time which is required currently to process 1 minute of dictation, well, in this completely manual workflow, and of course to reduce the average time to so that the patients and the clinicians would receive the final report. And this will be, so this user study is currently in progress, and this actually will show the actual performance of the system instead of just those word or error percents. Thank you very much.
You're most welcome, Mr. Notmunds. It is a much pleasure to hear your great presentation. Now the question and answer time. If you have a question related Dr. Notmunds' paper, we can take.
I don't think anyone from the audience might have
Yes.
a question. Do you have any questions for the presenting Dr. Gul?
If so, we can pass another presenter. Is it right?
Yeah, no worries.
Okay.
If there are any more questions, or if there are, please use the chat function. But we'll move on to our next presenter now. So I'll just share my screen. So our next presenter is Vasily M. Kundyshev from the Peter the Great St. Petersburg Polytechnic University in Russia. And his paper title is Computational Intelligence Technologies Stack for Protecting the Critical Digital Infrastructures Against Security Intrusions. So just stop sharing. So Vasily, whenever you're ready to share, present.
Yes, I'm ready. And I start the presentation. It's okay?
Yes.
Yes. Good day. My name is Vasily Kundyshev, and I represent the Department of Cybersecurity at Peter the Great St. Petersburg Polytechnic University. And the topic of my talk is computational intelligence technology stack for protecting the critical digital infrastructures, CDI, against security intrusions. Over the past decade, info telecommunication technology has made significant strides forward. With the advent of new generation wireless networks and the massive digitalization of industries, the object of protection has changed. The digital transformation has led to an increased opportunity for cyber criminals. The ability of computational intelligence to quickly process a large amount of data makes the intrusions tailored to specific environments. And based on the study of existing related works on the most common cyber threats aimed at critical digital infrastructure, 5 main tasks were identified that need to be solved. The first is a control of security function. The second is false data detection. The third is polymorphic attack detection. The fourth is dynamic routing anomalies detection. And the last is ultra large data processing. Thus, our study observes nature and related works devoted to the creation of intelligent protection against security intrusions relevant to the CDI. Based on this review, a computational intelligence technology stack is identified for solving the security issues in the current variety of cyber threat scope. The first task is a control of security function. We know that the nodes in CDI have small computing powers, which makes operation of power consumption protection at nodes difficult. The transfer of data from one node to another in such networks can occur even if these nodes are outside the zone of direct radio visibility. Data packets are relayed by other nodes of the network that support transitive communication. And for such networks, the main problems are guaranteed routing of packets between nodes, scalability of networks, addressing of terminal devices, and maintaining connectivity in conditions of variable topology. Together, this makes it difficult to manage and maintain security in a large number of nodes, rapidly changing topology, high node speeds, and limited computing power. To solve this problem, it is proposed to use the technology of software-defined network, SDN. An SDN is an intelligent system that directly interacts with the data transmission medium, and SDN is more flexible than traditional networks and allow one to dynamically make changes on routing rules in accordance with the tasks that the network must resolve. The control center in such network is a dedicated server with a software-defined controller. The SDN controller allows for the implementation of the principle of software-defined security, and the technology for managing the security of the entire network as whole using software network management services running on the SDN controller. For example, routing, monitoring, access control, etc. Connected via the OpenFlow protocol to the network devices. And for the powerful processing of large amount of information coming from the controlled network, supercomputer technologies of elastic computation are used. A form of a cloud computing that is expanded by the ability to dynamically prepare and release resources, processors, memory, and data stores, and a pool of software services to meet changing requests. The next problem is the false data injection, FDI attack, on data in smart infrastructure. FDI attack usually targets the sensor network widely used in industrial, Internet of Things, smart grids, smart buildings by entering false measurements into periodic measurement reports sent to the central control unit. An essential condition for successful FDI attack is passing an OS check and preventing anxiety. The attacker forms a false injection of measurement so that residual value is even less than the specified threshold. Then FDI can mislead the control center, forcing you to make wrong decisions that negatively affect network performance. And to solve this issue, we suggested a method based on spatio-temporal correlation and failure detection by modified Kaizen method in the operation of a smart network. The method includes two stages. The first is recognition of a spatial pattern, and the next is a failure detection by using Kaizen method using the Dempster-Sheffer theory. The next problem is advanced polymorphic attacks. At present, comparison with attack templates is the main method for IDS upon detection of malicious behavior. However, this method poses two significant drawbacks. Firstly, IoT-specific attacks such as forced energy consumption, forced topology change, and other have separated work sequence and time delay in a chain of actions, and some attacks could also have nonlinear work sequence. And secondly, polymorphic attacks have mutation in work sequence during attack. Such polymorphic attacks are adapted to a broad range of conditions, operating systems, and also try to avoid a scanning using protection tools in order to infect endpoints. To solve this problem, we proposed a sequence alignment algorithm from the informatics. We can see that DNA molecule stores biological information in the form of genetic code consisting of nucleotide sequences. Each record field whose format is determined at the traffic encryption stage corresponds to unique nucleotide sequence. The set of well-known protocols, services, flags, and other parameters of network packets can be encoded using these nucleotide sequences. Therefore, the values used during encryption are first determined for this data. The suggested approach has been adapted for low-performance devices of Internet of Things. And in addition, this method considers the specific character of network attacks aimed at Internet of Things and can detect such attacks as forced energy consumption and forced topology change. Also, as a result of detailed consideration.
Sorry, Mr. Vasily, sorry, you have 1 minute.
Thank you. As a result of detailed consideration, it was determined that many attacks on routing. For example, Daniel servers, black hole, gray hole, and other. And to solve these problems, we propose a swarm algorithm for detecting such attacks. The algorithm is based on ant colony, and the algorithm uses the trust model. The last task is that ultra large data processing. Now information security researchers and IDS developers have focused on the application of artificial intelligence and machine learning methods. However, processing not just big data, but huge data, such systems have a decrease in the accuracy and increase in the processing time of incoming packets. For solve this problem, we propose a quantum machine learning. For example, we analyze existing platforms and compare QSVM and QCN model. Also, we develop an encoded algorithm to transfer data into qubits. In conclusion, we propose a technology stack that give new opportunities to protect the CDIs. This is SDN, this is machine learning and artificial networks, this is bioinformatic algorithms, swarm intelligence, and quantum machine learning. That's all. Thank you for your attention, and I'm ready to answer to your questions.
Thanks, Doctor, for your great insights. Now it is the question and answer time. If you have a question, you can ask the presenter, or you can write the chat box. Yes, I So, Mr. Nordmans, have a question?
Thanks.
Yes.
I have a question regarding evaluation. Have you conducted some evaluation, and what is the metrics in this case? What can be used?
Yes, thank you for your questions. For each detection method, we make many simulations. We use a feature-grade supercomputer for this simulation. We use specific network simulations for prepare CDA network, like network simulation 3, like Sumo and other simulation. And we use the traditional machine learning methods like confusion matrix, accuracy, recall, precision, ROC curves, and other. We made experiments on well-known data sets and in our special prepared data sets.
Oh, thank you. So it's basically a classification problem, right?
Yes.
Oh, thanks.
Yes. Thanks for your response. Another question? Yes. Now we can go through another presenter. The third presenter is Dion Marianagam. Okay. Is it ready? After presentation.
Hello, can you hear me?
Yes.
Perfect. Yes, I will share my screen.
And so please.
Hopefully you can see this.
Yes, clearly.
Perfect. Thank you. Well, thank you for the introduction. Yes, my name is Dion. I'm a researcher at London Metropolitan University under the Department of Communication Technology and Mathematics. Now, my research topic is a bio-inspired framework for security in IoT devices. Now, please note that this is just the framework. The implementation is going to come soon. So let's get started. So I'll just give you a quick presentation overview. I'm going to introduce you to the topic. I'll give you a background to all the different topics that is covered as well. I'll go further into what is bio-inspired security. I'm going to talk to you about my current framework, and then we'll conclude and talk about the future work. So quick introduction. Essentially, what do I mean by what is the bio-inspired framework for security for IoT devices? Essentially, these are going to be the main aims for this. It's essentially interdisciplinary approach for IoT security that has a bio-inspired mechanism for intrusion detection and rejection of foreign agents. Sometimes this is called bad actors as well. It's lightweight for low cost and low processing power microcontrollers. This I'll get into more further down the line. It's a secure client and server communication stream, and also implementing a blockchain ledger integration for distributed credential information as well. So those are going to be the main aims for this framework. But before we get into more detail of that, let's go through the background. Like, what do I mean by all of these topics and keywords? So what do I mean by IoT? Well, many of you might know this already, but for the ones who don't, essentially IoT is Internet of Things. And what that basically means is that it's typically a device with sensors and actuators that are linked through a network and usually connects to the internet or intranet. Typically considered as energy efficient and low processing devices with at least one sensor. Now, common devices for common IoT devices are like smartwatches, automated weather stations, smart TVs, things like that. Typically we think that they are low processing power devices. However, there is a change. There is a more inclination to more higher processing devices coming to the market now. So why is IoT becoming a big industry now? Well, it's mainly to do with cost. It's always to do with cost. And the average cost for IoT devices have been becoming cheaper as the years go past. So for example, in just 2004, you can see that it was around £1.30 or $1.30, sorry, for each IoT sensor. Now the average cost for it is 38 cents. So it is reducing by quite a lot. Um, so the actual development for these IT devices are actually quite fast. So you can see that in this generic life cycle for IoT devices is that you will have usually the construction or a reconstruction of a device. You then deploy it, you grow it, and then comes the managing. Um, then after its life cycle is coming to an end, you either recycle it or decommission it. This usually means that you either add a new processing unit to it, or you change a few sensors out, and then you go and you put it back into the actual environment again. So that's the life cycle for IoT devices. Now, why is encryption important? What's the point of it? Because there's a lot of research and talk about it, but why do people consider it important? So sorry. Okay. So essentially, technology right now, I would argue that is in between the second and third person. Let me get the pointer out. Hopefully you can see the pointer. So I would argue technology right now is between the second and third person. It's slowly going into the third person. And this is right now for wearable technologies and more IoT devices connected to the internet. Eventually, there will be an amalgamation of humanity whereby technology will occur with more complex embedded biotechnology, whereby the data gathered is no longer only our habits, is also gathering data about our biology. Now, in terms of biology, I don't mean wearable technologies like your steps and heart rate, I mean your biochemistry. Um, and in terms of that, um, even though a company may know your biology and your biochemistry, is not as dystopian as it seems, because the health industry can really benefit from precise medical information that is 24/7, that is connected to you. Let's go to the next one. So therefore, your experiences and stimuli to certain situations and reactions makes you a data gold mine and a great baseline tool to model artificial intelligence and machine learning through this data collection. So you and your data is valuable, and anything that is valued should be protected. Hence why any data that is valued should have some form of encryption, should have some form of protection. And that is why IoT devices, that's why there's a lot of research for IoT devices to be encrypted. Now, polymorphism. Now, this was touched on a bit on the previous presentation. Essentially, what polymorphism is, when you're looking at it from the biological perspective, is essentially many different forms of types of individuals in the same set of species. That's essentially what the biological side of it is defined as. But polymorphism in the computer science and programming, well, it comes from the notion of type theory, whereby every single term has a defined type and defined operation. So in a nutshell, it's the same outcome accomplished through different operations. So for example, 2 plus 2 and 2 times 2, it's the same outcome, but the different operation. So if you tell an animal to speak, the outcome would be the same. They will all speak, but the operation would be different. I don't know if a fish will say splosh, but you can see how the different outcomes for the different animals as they speak in this. So let's get to the next slide. So what do I mean by bias by security now? Well, in this sect, in my framework, what I'm going to do is essentially have a cross-pollination between the biological field and the actual technological field as well, because human immunology translates to a novel security system for IoT devices. Now, humans have an innate and adaptive immunity in terms of immunology. So the innate immunity responds and recognizes generic targets on foreign agents like pathogens, whereas adaptive immunity recognizes specific targets using randomly generated receptors that have virtually an unlimited recognition repertoire. Now, there are two different types of adaptive immunity called hormonal immunity and cell-mediated immunity. So the properties of adaptive immunity. So this is what we're going to concentrate here. It's on this table here. So the properties of adaptive immunity are specificity, diversity, memory, conal expansion, specialization, contraction and homeostasis, and non-reactive to self. Now, all of these features are what's already in your body. All of these features are essentially how your immune system works. Imagine if you can translate that to a framework for IoT devices or even networks. That is what makes a novel security system. So coming into what the actual proposed framework right now, I'm not going to go into a lot of detail, but I will give you the brief overline because I think I'm running out of time. So essentially, I broke this down into three separate processes. So we got the approved client list process, the client connection logic, and the ledger process here. So the approved client list process is essentially a radius server, whereby we can get their credentials. We can also check if there's going to be a false positive or a false negative, if they're meant to be there or not. Now, the client connection logic is essentially checking if the client is approved. If the client is approved, then they get a copy of the ledger. If it's not approved, then essentially a trigger system is released, like a hormonal response, and therefore it's essentially saying, hey, this credential system is now compromised, so we need to alert all the connected clients to move away from this. And then we go on to the actual ledger process system. So the trigger, which is the hormonal response, essentially triggers a pseudo random number that points to an element in a ledger. Now, the clients then can change the credentials and encryption key using the shared ledger, which is given to the approved clients. And once they change to the new encryption key and the credentials, they can reconnect to the server. Now, if they successfully connect to the server, then a new updated credential list is given with the compromised credential out of the shared ledger. And if they can't connect to the can't connect back to the server, then they go back into the approved client list process. Therefore, anything that's out of sync then can come back into sync. Again, this is a very brief overview of this. And then for conclusion of future work, essentially what is presented is a novel bio-inspired framework for IoT devices which can auto-detect foreign agents, reject unauthorized clients, and has a polymorphic ability to change the credentials and encryption and the encrypted communication stream. So the next step for me is the real-world implementation. Now, the way I'm going to do this is I'm going to have three different categories of IoT devices. I'm going to have low-end IoT devices, middle, and high-end. Now, these devices are going to be categorized by their processing power, because that's one of the most important things for IoT devices is power consumption and processing power. The more processing power you do, the more power you consume. And these devices are usually mobile, and they usually have a battery. So you need to be very mindful on how much this security framework will impact the actual processing power and the power consumption of a device. So that is pretty much my presentation. I think I'm just under my time right now. But yeah, thank you for listening. If you have any questions, please do ask.
Thanks for your insights, Dr. Diane. I think it is very inspiring presentation. I took my notes related to my areas. Now it is a question and answer time. We have 3 minutes. Is there any question to Dr. Diane we can take? Or maybe write on the chat box.
I'm just
Yes,
curious.
Mr. Ramos.
Hi.
I'm curious about the blockchain part. Will you use some of the public blockchains, or will you create your private one?
Very good question. So I was researching this, and my God, blockchain is very, very heavyweight. Yeah. So what I was thinking is making my own one, and I actually started programming this in C, and then now I'm thinking I have to program this in a more lightweight in assembly code right now, and this has given me a massive headache. But I'm planning to actually make my own, which is a bit more lightweight and is a bit more focused on my design, because essentially what I don't need everything to do with blockchain, just parts of it. I just need parts of it to be more useful for my actual framework. So that's a very good question. The answer for that is I'm making my own, but I'm making more optimized to this framework, because if I get it from someone else, I know for a fact that is not going to be as efficient and be as optimized as I could. So I'm going to make my own from that. But thank you for your question. That's great.
Thanks.
Thanks for your kind response. Yes, another question. Okay.
If there aren't,
Mr.
sorry,
Matt?
if there aren't any, yeah, if there aren't any
Mhm.
questions from the audience, is there any questions from you, Dr. Gul, for the presenter? Sorry, do you have any questions for the presenter? Sorry.
Okay. Maybe I can ask a question to
Yep.
Mr. Dai.
Of course,
Uh,
yes.
Do you have any advice to other discipline, for example, tourism management or marketing related our future research?
Future research. Oh, could you ask that question again, because I didn't fully understand it?
Mhm. Okay, do you have any advice to other discipline, interdiscipline, about
Okay.
what is the roads or what should we do related your topics in the future?
Okay, so this particular topic, what inspired me was usually because I'm from a biology background, and then now I'm in robotics. Honestly, the more you talk to each other with different disciplines and different industries, the more you realize there's a lot of interdisciplinary problems that you can solve with each other's solutions. So for example, looking at human biology, looking at how the human immune system fights bacteria, fights viruses, and like COVID, bloody hell, that was a thing. Yeah. How can we then translate that to a digital system?
Mhm.
Well, look at what's already been done through nature. Nature has been doing this for millions of years, making sure that our immune system is ever evolving. What we need to do is really look at what's already existing, translate that to our industry, and then see if that will work. If it's not, then you can always change it a tiny bit to make it more optimized to your industry. So my answer to your question is, honestly, talk to each other. Communication is important, like barely anyone does it. Yeah. Talk to each other and just talk to each other about your problems as well. And you'd be surprised how your problem might be solved in a different industry in a different way. Just have to be a bit creative to put it into your industry, and that's it.
Mhm.
Then again, that's a very nutshell way of saying a very complex problem. But yeah, talk to each other. That's the best thing I can say. Thank you for your question.
Thanks for your response, Doctor. Yes, we can pass another presenter, Mr. Nahid.
Yeah, so we'll just move on to the next presenter. I'll just share my screen very quickly. So our next presenter is Monica Rabka from London University in the UK, and paper title is IoT-based horticulture monitoring system. So whenever you're ready to share your screen.
Sure, let me just do that quickly. Yeah, I hope everyone can see my screen.
Yes.
Yes, we can see screen.
Good afternoon, everyone. My name is Monica, and I recently graduated in computer systems engineering at London Metropolitan University. Today, I'll be presenting you my framework for my final year undergraduate project within the Department of Communications Technology and Mathematics. And it's called the IoT-based horticulture monitoring system. Just a little overview of my presentation. I will go over the introduction to the research topic, then I'll cover the design and implementation and resulting product. I'll mention a few obstacles faced during the design and testing, and then I'll finish up with data collected and future work in conclusion. I hope you enjoy this presentation, and let's go straight into the introduction. So in the times of climate change and global warming, alongside the global population growth, which is expected to rise by 2.4 billion by 2050, increasing food security has become an important area of research for scientists. Also, with each degree rise in temperature, it's estimated that we will lose around 10% of existing agricultural land. As a result, we need something to combat that. So vertical farms, hydroponics, and urban greenhouses are being deployed in cities worldwide, like this urban farm located in Hong Kong, shown in the picture. Controlled environment agriculture is a sustainable response to the increased demand of food, and also reduces the food wastage and production losses as it eliminates the pests and pathogens found in the outdoor farms. So the research topic for this project was the design and implementation of an IoT, Internet of Things based embedded system called Real-Time Autonomous Horticulture Monitoring System, RAMS for short. I'll be calling it RAMS from now on, which monitors various parameters integral to controlled environment agriculture. So let's get into the design and implementation. The goal for RAMS was to achieve a solar-powered, low energy consuming and inexpensive greenhouse monitoring system. This has been achieved with the client-server architecture model design, which has potential for further scalability. The system uses inexpensive and commonly used in the industry ESP32 microcontrollers and cost-effective sensors, which I'll talk more about in the next slides. In this slide here, we can see a top-down diagram for the design of the system. The main part of the system is the RAMS client, which is the gray box on the left, the smaller box. And it consists of the ESP32 powered sensor board and a camera server, which in our implementation is also an ESP32 microcontroller. There's basically a lot of ESP32 microcontrollers involved in this project. These microcontroller units were used due to their built-in Wi-Fi capabilities. So they're inexpensive and they have already many things built into them, which is quite convenient. To achieve sustainability, all components of the client are powered with a solar power bank with 5 volts. And then the rest of the system is in the cloud and the server is powered with regular DC current. So aside of the RAMS client, another important part of the system is the ESP32 server, which acts as an access point for the sensor board, while at the same time connecting to the internet to send the data to the cloud. The communication between the sensor board and the server is through HTTP requests, which could easily be scaled up for multiple clients if needed by adding additional web pages to the server to receive the extra data. The camera server, however, connects directly to the internet, and MATLAB ThinkSpeak API, as well as the bespoke Android mobile application that has been created for this, they access the photos directly from this camera server. Additionally, the ESP32 server interfaces a GPS module, which is used to store the server's location in the database along with the values sent by the server. So if many devices are deployed, we know which server is where. For example, if we have many greenhouses that we want to cover. Onto the next slide, the implementation. The RAMS client is interfaced with the range of sensors which are integral for controlled environment agriculture. Carbon dioxide, water, and sun are all needed for photosynthesis to take place, and as such, the following sensors were used. The air temperature, humidity, and pressure, BME 280 sensor by Bosch SensorTech, which is quite inexpensive. CO2 and total volatile compounds, CCS 811 sensor by AMS, soil moisture and waterproof soil temperature sensors, and light-dependent resistor for detecting the light levels. The RAM sensor board comprises of all these sensors and an ESP32, and it's shown on the left with the custom PCB that was designed for this project. On the right side, we have the camera server, which is an ESP32 camera module. And this is used to take photos in real time of the crops for any disease detection. For system testing, a proof of concept 3D printed casing with a custom designed printed circuit board, as shown previously, was produced. This casing has been printed using wood-based filament. This specific filament has been chosen because the combination of wood and PLA results in composite filament that is largely biodegradable. And then this 3D printed box was deployed in a small greenhouse in London over the period of 24 hours. And as you can see, there's a little orange power bank attached at the top in the picture on the left. There were a few obstacles during the design and testing for this project. As you can see in the top picture, the 3D printed case that was left in the greenhouse for extended testing over the following days after the initial test, which also turned out to be the hottest days in May in London with over 27 degrees Celsius. The result, as you can see, the casing did not withstand the UV light and temperatures inside the greenhouse. And as a result, the box was warped. With the next iteration, this could be improved by using different box design, for example, thickening the walls or supporting the joints, or even changing the 3D printing filament for ABS or PETG, which could withstand the exposure to the elements better than the wood-based filament. Additionally, the camera server had to be tunneled for public web access using a tunneling service. The service that we've used was the NGROC service, as you can see on the picture at the bottom. That have been achieved using a Raspberry Pi to tunnel the IP address of the local server, or local camera server. Going on to the data that was collected, the Firebase real-time database is was structured using date and time taken from the network time protocol to organize the data in a clear manner. The database nodes start with the main sensor board name node, within which there are date nodes and then time nodes, and then lastly, a key value of the sensors with the collected environment values. As you can see in the zoomed bubble, we've got the key for the sensor, and then the value is the collected value from the environment. Additionally, within the main sensor board, there's also a node with the location, which I already mentioned before. This is for multiple greenhouses so that they could be differentiated with the location node. For the Android application, this has been designed from scratch to display the database stored values in the latest crop photo. This enables users to directly view the greenhouse crop data and the picture all in one place. The app connects to the database directly, so it gets updated in real time as the values get uploaded to the database. Additionally, the app also has a logging in system for a little bit of security, as this has been a year-long project. security hasn't been looked into that much, but as little as we could have done was the logging in system for the app. Now onto the MATLAB ThingSpeak. The same values that are being sent to Firebase are also sent to MATLAB. They get visualized on graphs against time, as you can see on the picture. And then additionally, we're doing image processing on the picture taken using the camera server. Here's a slightly better picture of that. So you can see the difference between the processed and unprocessed picture. The plant that you can see in here are tomato plants. Image processing was performed using simple algorithms like RGB to gray conversion and thresholding methods, which are shown on the picture on the right. This was a proof of concept implementation of image processing using the ThingSpeak cloud. So more suitable and advanced algorithms should be used for better results. For future work in conclusion, the proposed system has a potential to further advance the practical aspects of remote solutions for the cultivation and monitoring of horticulture and controlled environment agriculture. However, as with anything, this research could vastly benefit from some improvements. Some of the future work suggestions include minimization of the complexity of the network architecture using a 4G LTE enabled microcontroller, which would completely scrap the server. Over-the-air implementation for the remote firmware to be uploaded. Addition of actuators, for example, a watering system, fans or shaders. Obviously, as I mentioned previously as well, introduction of IoT security with encryption or by using client credentials. And what I think would be the best one, a notification system so that the app could send notifications when critical things are happening to the greenhouse, like too high temperature or too little water. To conclude, this research proposes a solution for controlled environment agriculture, as recent implications of the COVID-19 pandemic prove that as a society, we can harness the benefit of remote monitoring and automation for the food producing industry. Thank you for your time, and I hope you enjoyed this presentation.
Thanks for your insights, Dr. Monica. Now it is a question and answer time. Is there any question? Yes. Okay. Mr. Knight, is it possible? Yes.
So, do you have any questions for the presenter, Dr. Gill? If not, we can move on to the next presenter.
Maybe I have a question to what is the main obstacle from her experience during research, and what is the main suggestion to researchers related to their difficulties faced by?
Sure. So for myself, obviously, as it was my undergraduate project, the difficulty was integrating everything all together. So I've researched existing case studies, and I've seen that many of them were focusing on different aspects of it, never integrating it all together into a small, cohesive, inexpensive unit.
Mm-hmm.
So that was quite difficult to find a way to use these inexpensive microcontrollers and have a positive result. But all I can say is that testing, that was pretty much how I managed to do it, and just finding different ways of and trying to get to your results.
Thanks for your kind response. Yes, Mr. Knight, is it possible to pass another presenter?
Yep. So thank you for your presentation, Monica. So we'll just move on to the next presenter. So hopefully everyone can see the screen. So the next presenter is Villiers Portapas from the University of West England. That's in the UK, not the US, sorry. And his paper title is Targeting Global Environmental Challenges by the Means of Novel Multimodal Transport Concept of Operations. So Villiers, whenever you're ready.
Thank you. Can you see my screen?
Yes, surely.
Okay. So, good afternoon, everyone. My name is Villiers Portapas. I'm a lecturer of aerospace systems in University of the West of England in Bristol, in the west part of the UK. Today I will present a presentation about the targeting global environmental challenges by the means of novel multimodal transports, and particularly the concept of operations that we are proposing. I want to emphasize that this presentation is based on the paper that I submitted in April or in May, so a couple of months ago, and all the information presented will be not the up-to-date information, but the same that was submitted in the paper. Okay, so the content for today is the introduction to the research topic, current issues with traffic flow that we are seeing, proposed concept of operations to mitigate these issues, verification of the proposed concept, maybe more proposed verification, and conclusions and future work. So to introduce the topic, there are numerous initiatives to reduce CO2 and NOx emissions globally, right? So in air transport, we have ICAO, International Civil Aviation Organization. We have European Conference of Aviation. We have different work groups like ATAG, and they all have different initiatives like Flight Path, Waypoint, and etc. In the marine transport, we have International Maritime Organization, which also has initiatives to reduce the CO2 and NOx. However, in the transportation, it's quite hard to achieve those targets because they're usually to reduce CO2 and NOx by 50 or 70%. So what we actually need is not to improve the propulsion systems, but to change the fuels. And what we are proposing is to use these sustainable fuels such as electricity, liquid hydrogen, and ammonia. I will not dig deeper into how much emissions must be produced to produce electricity or ammonia or liquid hydrogen, but if we use those fuels to propel the transport, different modes of transport, the transport itself becomes sustainable. And so this is based on the current research project, which is called Dog-to-Dog project, and we will use multimodal transportation system, so electric vertical takeoff and landing vehicle, like flying taxis that you saw probably in public announcements, and electric autonomous zero emission vessels. And this is being done between Bristol and Cardiff, so that in the next slide, I can introduce you Bristol and Cardiff. So this is west part of England, and on the left side, you see the Cardiff, which is part of Wales already. And between Bristol and Cardiff, we have the Severn Estuary, so that's a river which, the estuary of a river that width depends on the tide of the ocean. Okay, so it becomes more water or less water in this place. Anyway, there is between Bristol and Cardiff, there are around 4,000 trucks and vans carry goods every day. So these numbers are pre-COVID and probably post-COVID. They will be very similar. Usually there is one transport link, and this is the black line across the water. Okay, so this is the bridge, and that bridge usually is congested because there are not only trucks and vans, there are also many personal vehicles traveling through. So to cover 60 kilometers by land, it usually takes 50 to 85 minutes, again, depending on whether it's a good traffic condition or it's congested traffic or traffic jams. So what we are proposing is to use the electric vertical takeoff and landing vehicles, eVTOLs, that would reduce the path to 32 kilometers and 12 minutes of flight, or marine vessels, ships that would take 37 kilometers and 96 minutes of the duration of the trip. Right. So we have flying vehicle and we have ship, okay, in our concept of operations. With a flying vehicle, we can achieve almost 200 kilometers per hour flight speed. So it is a fast delivery. However, with a ship, although it's a slower mode, we can deliver larger goods. So with a flight, we can achieve around 300 to 400 kilograms of payload, while with a ship, we can achieve hundreds of tons of payload. Now, with VTOL, we have a capability of being more flexible, so we have more places to land. Although there is a common understanding now that we need a heliport or some certified place to land, but if we take a look at the helicopters, they land pretty much wherever they want, as long as there are appropriate environmental conditions or surrounding conditions to land, so no high trees, no electricity masts, and no people living around, right? While with the ship, we need infrastructure, so like a harbor or port, so there is a less flexibility. Now, with the proposal of eVTOL, we have a modular design. So if you see at the top picture, we have a flying frame, and in that frame, there is a blue cabin. And that blue cabin is detachable. So if we detach it, we can attach another one and make the airframe fly again, while we refuel the detached cabin one and we reload it with different cargo. Now, what is the main point of this? It's a hybrid propulsion, so hydrogen or electricity, which makes these modes of transportation environmentally friendly. Now, the modes of transportation is one side of all the picture. Another side of all the picture is actual hydrogen infrastructure. So we know that to produce hydrogen, we need most probably to do the electrolysis. And as long as we have renewable sources of electricity, we can say that production of hydrogen is quite environmentally friendly. However, the transportation of hydrogen and storage of hydrogen is very challenging, as it requires very low temperatures, below minus 200 degrees of Celsius, or usual temperatures of around 0 degrees to 10 degrees of Celsius, but then very high pressures. So the dock-to-dock ecosystem consists of obviously the sources of hydrogen, infrastructure of producing it and storing it and transporting it, and then distribution. So on the distribution side, the dock-to-dock infrastructure would consist of, in this case, it is airside. So some demonstrator will be done next year in the Gloucestershire Airport in England. So the idea is to be able to refuel commercial and private jets or any kind of flying vehicles, to support ground vehicles, and also the public transportation like buses, taxis, and rental cars. Okay, and below you can see the design of such a hydrogen distribution system, which is in the yellow containers. Okay, so it is of a size of 1 or 2 standard containers that you can see on any container ship. So it's called 40-foot container. It is, for the demonstration, it is supposed to be transferable, okay, so that we can take it from one place to another, from the airport to the harbor, and etc. And in the blue parts of this container, the hydrogen will be stored, or ammonia. Okay, so that's about the infrastructure. Now, the proposed route. So you saw the Bristol and Cardiff on opposite sides of the water area. Okay, so on the right-hand side here, you have GBAVO, which is Bristol, or Avonmouth, and Cardiff on the left. It's actually a very good place to have a demonstrations because we have a Class G airspace up to 3,000 or 4,000 feet, depending on the position of the flight. And we have radar surveillance for the aircraft demonstrations, okay, radar surveillance above 2,000 feet. So we are basically in a controlled airspace, and we are surveyed by the radar. So if we know where our aircraft is, and we can also do the beyond visual line of sight operations for demonstrations.
Sorry.
Yes, I have 2 minutes.
Okay, thanks.
Yeah, so we can do the demonstrations here. Going further, so we are proposing 2 parts of two-step verification of our concept of operations. The first one is to produce the digital twin of the airborne system, so of eVTOL. And to do this, I'm considering the flight dynamics model and communications model. So just to make sure that our aircraft is always covered by GPS and 5G communication, so we can, in case of any emergency, we can have a communication with the aircraft. For the ship, it would be very similar. Now, for the energy requirements, we are considering requirements in terms of energy units, so whether it's kilowatts or kilowatt hours, power or energy, it doesn't really matter, as against the monetary value, because in different parts of the world, there are different costs of energy. Now, if we go further to conclude and further work, so to conclude, there is a shorter distance between the docks by air or water rather than by the road. We have the radar surveillance for eVTOL flights and ships, so we can have the follow-up of our vehicles if they're unmanned, and we have multimodal hybrid powered transport that would reduce environmental impact. Now, for future work, it's to finalize the energy requirement study, which has been already done, and to finalize the digital twin development and study, which is approaching the end currently. So maybe in the next conference, I will be able to present the results. And now just to acknowledge, this is our consortium, Neoptera, which is designing the electric vertical takeoff and landing vehicle, SmartPorts, which is designing that yellow and blue system for hydrogen, providing hydrogen. University of the West of England, it's myself, and Cardiff University working on hydrogen. And just to mention, this research described in this paper has been funded by the UKRI Future Flight Challenge competition under the project called Dog-to-Dog Hydrogen eVTOL Freight Transportation. So thanks to UKRI Innovate UK funding. And that's it. Thank you very much. And if you have any questions, I'm ready to answer those.
Thanks for your great insights, Doctor. Now it is a question and answer time. Is there any question to Dr. Vasily? Yes.
Okay, so anyway, just to say that if anyone is interested in what we are doing, we are going to go for Future Flight Challenge 3. If you have any ideas, especially about the quantum computing, there was a presentation from Vasily. We would be interested to hear from you. Just apply quantum computing in the aerospace engineering sector.
Thanks for your kind concern, Doctor. Yes, Mr. Nahid.
Yeah, if you haven't got any questions,
Okay.
if there aren't any more questions, then just proceed. So I sincerely want to thank all of our authors for their excellent presentation and contribution in this session, and all of our participants for being part of this international conference. I hope this session was very informative. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months, so kindly cooperate with the team of WS4 2021. I would also like to thank the session chair, so Dr. Gül Erkal Bayram, for chairing this session. And I'm just gonna quickly share my screen once again. So this certificate is a token of our appreciation to the chair on behalf of Team World S4 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence. So I'd also like to request if everyone could turn on their cameras for a quick snapshot of the virtual conference.
Yes, Dr. Gul, if you want to say a few words with all the presenters.
Yes, thank you so much, Professor Mir. It is a great pleasure for me to be here in this very informative and fruitful event. Today we have a very successful presentation, 5 presentation, and I hope it will be virtual. Now maybe it can be a virtual conference, but after the COVID, we will have a conference with face-to-face, maybe in Turkey. Thank you so much for every presentation.
Yes, thank you, everyone. So now we will take one virtual photograph just for the memory, and we will share with everyone.
Thank you very much, everyone.
Yes, thank you very much, everyone. And again, big thanks to Dr. Gul and all the presenters, and hope to see everyone in physical mode next year at London 2022.
Yes.
Thank you.
Thank you.
Thank you.